Hi, I'm Tony Northrup for TrainSignal, and in this video lesson, I'm going to cover access control concepts for the SSCP certification exam. Up first, let's go over some important access control policies and general best practices. Up first, one of the most fundamental concepts, and that's the concept of least privilege. And what this idea says is that you should give people no more permissions than they absolutely need to do their job. And what that means is you give them the exact privileges that they need to do their day-to-day tasks and nothing more. Let me tell you why that's important. Now imagine that I work for an IT department of an enterprise, and my job is to help people with their email problems. And in enterprise, this is definitely a full-time job. So day to day, I'm helping people configure their email clients and troubleshooting spam problems and responding to complaints about phishing emails, perhaps. But imagine in this IT department that the standard privileges for all people in IT are the domain administrator privileges. They just give everybody the permission to do anything that they need on the network, to modify any file on any computer, to read any file, to install any software that they might want. Now, this works fine. I'm able to do my job with those privileges, and on a day-to-day basis, I'm sure nothing happens because I'm a trustworthy person. But imagine that as I'm browsing the web, I visit a website that itself has been infected by malware, and it exploits a vulnerability in my browser that has been unpatched. This can get malware on my own personal computer, and that computer, in turn, could use my domain admin privileges to spread the malware to every computer in the organization. At that point, it's common for malware to alert an actual human being who can log onto the network and begin to browse the files and maybe look for some confidential files that could be used to make some money, maybe by selling or buying stock early with the advanced knowledge of the company's future plans, or it could be used to extort the company. So that's how that unfolds when somebody has far too many privileges. In the least privilege scenario, I'm helping people with their email, and I have permission to do nothing else. I can go in and check people's email settings, and I could probably go in and install new email clients on new computers, but my privileges would be limited to exactly that. So I get a malware infection, and it can't spread to every computer in the organization. It might be able to install itself on my own computer, but it might not even be able to do that because I don't necessarily need permissions to install apps on my own computer, even though I'm in IT. This is the concept of least privilege, and it's there to protect users from accidentally hurting themselves and to protect users from malware infections that would exploit the rights that you have. Now, least privilege doesn't prevent security compromises. Instead, it minimizes your risk by reducing the potential damage from a successful security compromise. So in both of those scenarios, both with and without least privilege, we still suffered a security compromise. I still managed to get malware on my computer. But in the least privilege example, the malware was able to do far less damage than it would if I had unlimited access to the domain. So even if you have the right to have unlimited access, you need to resist that temptation, because you can do more harm than good that way. Now, all modern client operating systems enforce some level of least privilege when a typical user logs on. For example, starting with Windows Vista and including Windows 7 and Windows 8, when a user logs on with an account that has administrator privileges, that's an account that's in the administrators group on the local computer, well, the computer actually makes a separate little token for the user, and everything they do runs with standard user privileges. In other words, a normal user who doesn't have rights to install software. Now, this is weird, right? Because the user is a member of the administrators group, but the computer actually takes those privileges away and says, here's a lesser privileged account, do what you need to do with this account. Now, if it comes that the user needs to install some software or do something else that requires administrative access, Windows asks them. It says, hey, are you sure about this? It does that using a user account control prompt, a UAC prompt. So it requires the user to confirm it. And if they confirm it, then it elevates their privileges and gives them access to the full set of administrator rights. I used Windows as an example, but all major operating systems, Mac OS X and all the various Unixes and Linuxes, all have a setup similar to this, where you log on with standard user rights and then you elevate your privileges whenever necessary. This reduces the risk of you accidentally making changes while still allowing you to intentionally make administrator changes. And that is the fundamental concept of least privilege. You don't have to give up control. You're just making it so that you can't make changes accidentally. Nowadays, many applications even run with least privilege by default. For example, if you run a JavaScript app in a web browser, this is a little client-side app that runs inside many web pages, and they're typically done to do things like make a slideshow or make menus expand. Well, these are little apps, but they don't have the rights to install other software on your computer. That would be crazy. If JavaScript apps were allowed to install software on your computer, every website you visit would be installing a toolbar or some sort of malware. Instead, the way it works is JavaScript is sandboxed. It's put inside a little virtual container, and it's allowed to do some things, like draw a menu on the screen or change a picture in a web element, but it's not allowed to access your documents or install software. That's because JavaScript runs in a least privileged environment. And in the Windows world, you'll see this with .NET Framework apps, and in the Windows 8 world with Microsoft Store apps, what they call the Metro apps. This is an example of how least privilege can be applied to applications. And besides preventing malicious apps from actually running, it also prevents legitimate apps from being exploited by malware. I'll give you another application example. Imagine that I'm writing a solitaire app in the Windows environment. There are a couple of ways I could do it. I could run a full Windows app that runs with full permissions. This is kind of the Windows XP way of doing things, so it's a little bit older way of doing it. The app runs with all the privileges that the user has. Now, all that app does is draw stuff on the screen. It doesn't ever need to access files. And indeed, I'm a good developer and I don't put any malware in there, but I do make an oversight and I leave a security vulnerability in the app. My app becomes popular and a malware writer discovers that it can exploit a vulnerability in my app to elevate its own privileges and access the user's files. Now, that malware can run rampant. Anywhere my app is running, that malware could exploit that vulnerability and do bad stuff. So my app isn't bad, but because it did not use least privilege, it got used as a channel by malware. Now imagine that same scenario with least privilege. I write a solitaire app, but this time I use a sandboxed environment, such as the Metro or .NET Framework. With these particular application development environments, I can give the application permissions to draw cards on the screen and interact through the mouse and keyboard with the user. But I can completely remove its ability to communicate on the network or access files. Now, my .NET Framework app has a security vulnerability as well, and a malware author discovers it and exploits it. And they're successful. They successfully exploit the app. But they can still only elevate their privileges up to the privileges of the host app. So they can only draw on the screen or interact with the mouse and keyboard. They can't send files over the network or even read the user's files at all. This is the power of least privilege and sandboxing. And now let's talk about a very closely related concept, and that's separation of duties. Separation of duties takes what would be one job and splits it into multiple jobs to help prevent a conflict of interest. So we'll start with an example. In the software development world, there are always a group of programmers, and one programmer will write the code, and then there'll be a code review. And other programmers will review his code. And not only is this good for getting feedback, they can say, oh, you should be using a different type of object for this, it would make everything run faster. But it's also good for security because you can't trust every programmer. Imagine a scenario where a programmer wants to put a back door into an app. Maybe you've seen the movie Jurassic Park. That's the most famous example of a back door. And the really disgusting programmer puts in this back door so that he can gain access to some really highly valued products. Well, in this case, they're dinosaur eggs. That might be where my real-world example starts to break down. But he puts his back door in so he can make money off of the app that he's developing. But not what he's being paid. He wants to make something on the side, and that's illegal. There was no code review. He was the only developer on the project. They trusted him completely. If there'd been code review, somebody would have reviewed his code and they would have been like, what's this code here? It seems to shut down all of security when you put a special password in. This is separation of duties. You have one person developing the code, and then you have somebody else reviewing and approving it. So before that software could ever go into production, a second person would need to review it, approve it, and then probably digitally sign it. And then on the production systems, you would configure them to only run digitally signed software. That separates the developer from the production environment completely and makes it very difficult for the developer to slip malicious code past. It's still possible. You can hide code, and sometimes reviews don't catch everything, but it means the developer is going to be taking a big chance, because if he gets caught, he's going to lose his job. So just having that review process in is probably enough to stop any security problems from happening. So imagine that you have one person who's doing the design, implementation, and auditing of a firewall system. And this would be common in a small organization that only had one IT guy, right? Well, he could do research and determine that the firewall needed to block a particular protocol. Let's call it ICMP. Now, he's designed the firewall and he goes to implement it, and he turns on ICMP, but he decides some apps don't work when ICMP is blocked. Now, he's also in charge of auditing it. So when he goes to audit it against his original design, he, of course, notices that ICMP isn't blocked like the design said, but he kind of shrugs it off. He's like, well, that's okay. What am I going to blame myself for it? I'm just going to overlook it. I know it didn't work right. So what happens then? ICMP isn't blocked, and maybe an attack gets through and the company gets compromised. Now let's look at that same scenario with separation of duties enforced. Imagine you have 3 different people in charge of the design, implementation, and auditing of that firewall. The design is the same. We need to block ICMP. The implementation guy runs into the same problem. I tried to turn on ICMP, but it broke everything, so I allowed ICMP through anyway because that's what I needed to do to make the apps work. The guy who audits it comes along and discovers that it's not working, and he contacts the design guy. He bypasses the implementation guy and he says, hey, you said you wanted ICMP enabled, it's not actually enabled. He doesn't have a conflict of interest because he's not the one who's going to look silly for not implementing it correctly. That's why you want a separation of duties between the auditing and the implementation, and probably the design as well. Now, the designer can go to the implementation guy and say, hey, this is really important. We need to figure out why so that we can prevent an attack from getting through. With separation of duties, things tend to get done a lot better if there's not any separation of duties. Stepping outside of the IT world, another example is that you should have different people hiring and paying contractors. Now, imagine that you have one person who's in charge of interviewing contractors, and they're also the ones in accounts payable writing the checks out to contractors. Well, if that person's a little corrupt, maybe he hires his buddy, and he overpays him a little bit in exchange for kickback from the buddy. Kickback is when you hire a friend and you overpay them a little bit, and then they give you a chunk of it back personally, kind of off the books. It's a way for an individual to steal money from a corporation. It's illegal and it's wrong, but it happens a lot. Now, in most organizations where they implement separation of duties, they'd have somebody different evaluating the contractors and actually paying them. They'd probably also have somebody separate reviewing the contract to make sure that it was fair. Especially in government organizations, these things are really closely followed because there's been lots of incidences of kickbacks in the past. So in this case, separation of duties would prevent the kickbacks from being in place, and it would save the company some money and prevent an illegal act from happening in the first place. So in summary, separation of duties limits misuse of systems and data by not allowing one person to carry out every part of a plan. It restricts the powers of individuals and puts in some checks and balances. You see this a lot in government. If you look at the American government, it's broken into 3 separate branches: the executive branch, the judicial branch, and the legislative branch. And they check each other's power. If one of them starts to do something corrupt, there's always a mechanism for one of the other branches to rein them back into control. And you need to implement similar systems within companies, and even individual departments. Don't trust somebody with an entire process from start to finish. Make sure that the job is broken up. Here's one that most of us well-meaning people won't complain about: mandatory vacations. Now, this doesn't seem like a security policy, right? But it actually is. Now, if you're a legitimate good guy and maybe you're working 80 hours a week and you're behind on your job, you might find it frustrating, believe it or not, if somebody said you have to take 2 weeks off, because you're like, well, I'm going to get back to work in 2 weeks and still have to get caught up on my job. Why are you making me leave? It's just going to end up making me more frustrated. So that's the downside of mandatory vacations. But let's imagine that you're actually a corrupt accountant and you're writing checks to yourself and making some money on the side. Now, the mandatory vacation comes up and you have to leave for a couple of weeks. Well, guess what? Somebody else has to take over your job. So maybe they have to hire a temp, or they pull in somebody from another department to cover that person's work. Well, they're going to discover the fraud, or at least they might uncover it. Whether or not they will discover it, the possibility that they'll discover it will be planted in the accountant's head, and it will probably be scary enough that he won't want to do it in the first place. So mandatory vacations allow other employees in the organization to see what it is each other is up to. When you're physically there, you can be actively hiding evidence and cleaning stuff up and making sure that nobody pokes their head in your files. When you leave, you never know who might be snooping around. So not only is it an opportunity to actually catch bad guys in the act, but the possibility of being caught is often enough to prevent people from doing the bad stuff in the first place. So it's also a very preventative and proactive countermeasure. Vacation time is also a good time to perform an audit of an employee's work, because after all, if somebody is up to something and they see that you're sniffing around, they might sabotage it or try to cover stuff up really quickly. Often mandatory vacations are only required for people in higher ranking positions, or people working with money, for example, people in accounting or finance, since those positions are the ones that have the most potential for job abuse. Another way to accomplish the exact same thing is job rotation. With job rotation, people trade jobs for a little while. And from a business perspective, there are lots of reasons to do this besides security. If you are a database admin and you take over the website administrator's job, well, you get to understand that person's job a little bit better. You get to explore some new technologies, and it could actually make you a better database admin to see how the front end kind of works. So you can actually improve skills and make your day-to-day job a little bit more interesting, and you get to know other people in different departments and you make connections. So if you read business books, you'll see there's lots of good reasons to do job rotation besides security. But from a security perspective, job rotation, just like mandatory vacations, is an opportunity to expose potential fraud or simply negligence if somebody is simply doing their job incorrectly. Having somebody else take over your job is a little bit intimidating, even if you're a good guy. But if you're a bad guy, it's really scary. If somebody's going to be sitting in your desk and doing what you do on a day-to-day basis, they might just discover what you're up to. And you know what? You're probably going to be too afraid to do that stuff in the first place. So it can be pretty scary for potential bad guys when they're kind of mulling it over. They're like, I can get away with this until John over there comes in and sits on my desk for a week, and then I'm totally going to get busted. So I'm just going to not do it. Job rotation works pretty well in large companies where you have 5 people working as website administrators. When you're a smaller company and you only have 3 employees in the first place, well, everybody ends up with a pretty specialized set of skills, and job rotation might not work as well. Now let's talk about some different access control models and how they're used in the real world. Up first, let's talk about discretionary access control, often called DAC. Now, DAC is something you're probably familiar with, but with an unfamiliar name. Now, I don't know why they use such an obtuse name as discretionary access control, but discretionary just means users can decide what permissions other people have to their files. So this is what you see in Windows and Unix file systems, and you know what? This is the way most of life works. If you buy a car, you can loan your car to a friend, right? You have that option. If you're having a house party, you get to invite who comes over. Nobody tells you that you have to invite everybody. Well, maybe they do if it's a wedding. Discretionary access control is flexible, but it's not especially secure. Bringing it back to the IT world, giving each user the ability to choose the permissions for any given file is error-prone. Now, if you're a security expert, you're going to be pretty aware of who you share all the files with. But imagine you're Mary in accounting. Mary has a spreadsheet with everybody's payroll information in it, and she needs to share it with her coworker. However, she doesn't really know how to use the system for sharing files and setting permissions, so she just decides to share it with everyone. This happens a lot. You just want to share it with one person, you're like, well, nobody's going to notice it. I'll just share it with everybody. And it's easier than trying to ask somebody for help on how to do this. So in this case, discretionary access control really fails because we're giving the power to people who aren't trained or careful enough to do it. It could also happen as a result of fraud. Somebody could call Mary up and say, hi, I'm your boss's boss, and it's really important that you share this file with me. And Mary would be intimidated even if they were lying, and she might go ahead and share the file. So by giving each user the right to decide whether a particular file is shared or secret or confidential, well, you allow everybody to make their own decisions, and we as humans are flawed, and we're also prone to manipulation. Now let's talk about the opposite of discretionary access control, which is non-discretionary access control, also known as mandatory access control. It's kind of right there in the name. It's no longer discretionary, it's mandatory. The access control is defined by management or IT or somebody higher up, but individual users don't get to choose who to share a file with. So this prevents all the problems with users inadvertently or intentionally sharing it with people they shouldn't. It also takes away a lot of the flexibility. Let's look at a scenario. If your buddy Tommy over in IT comes up with a great idea to improve the company by being a little more efficient, well, he might write a document with it. And, maybe he wants to show it off. So he shares it with a whole bunch of people. However, that document, if it's actually going to be useful, should be considered extremely confidential because it would give that company an advantage, and certainly the competitors would like to know about that document. So that document should be treated as confidential, but the guy who created it doesn't necessarily understand just how important it is. In a discretionary access control environment, he could share that with everybody and perhaps even completely devalue his idea by allowing it to get to competitors. In a mandatory access control environment, he'd create that document and then somebody else would need to determine what the level of confidentiality for that document should be. And if they wanted to share it outside of that level of confidentiality, well, they'd have to talk to their superior, somebody who had access to change that level. So mandatory access control is more secure, but it's also a real pain, and it doesn't work out all that well for corporations who need to move quickly and need to encourage communication between employees. It works really well for government organizations, though, who tend to use these really structured systems for securing documents like confidential, secret, top secret, unclassified. That's where mandatory access control really shines. You'll find that even people in government organizations tend to find it a little frustrating, but they're forced to deal with it, and if a nation's security depends on it, well, what choice do you have? Here are some examples of mandatory access controls. I already mentioned the military classifications. 4 different implementations of it: Honeywell's SCOMPS, the United States Air Force's SACDIN, the NSA's Blacker system, basically a mandatory access control system, and new in Windows Server 2012 is a dynamic access control system, which you can use to implement mandatory access control in the Windows environment. Earlier versions of Windows didn't have that built in. You'd have to have bought some third-party software and added it on. In the real world, we see an example of mandatory access control in liquor stores. It depends where you live in the world, but where I live, you have to be 21 to buy liquor from a liquor store. The government made that rule that says anybody over 21 can buy liquor. Anybody under 21 cannot buy liquor. The guy at the liquor store has to check your ID. That's part of the overall access control system. But he doesn't get to decide who he gives liquor to. He has no choice. If there's a guy over 21 that he doesn't want to sell liquor to, he still has to sell liquor to him. If there's a teenager that comes in and he wouldn't mind giving him a beer, well, that's illegal. It's a mandatory access control system, and the person distributing the liquor at the liquor store doesn't get to make the choice. That would be a discretionary access control system. Now, role-based access control isn't a third option per se. Role-based access control is typically used with a discretionary access control system. It is basically assigning permissions based on a user's role, which in most implementations is implemented as a group. For example, the people in the accounting department probably need access to the financial databases in your organization. So rather than assigning rights to Mary in accounting and Johnny in accounting to the database, you put them both in an accounting group and then assign that group permission to the database. Any given subject, a user, can be added to one or more roles. So if Tom is the manager of the accounting department, he might be in the accounting group and he might also be in the managers group. Who knows, he might be in the East Coast office group too. You can then assign privileges to each of these different roles, and the user will get the cumulative effect of all of the different privileges that they have assigned by different roles. Role-based access control really simplifies administration by not requiring you to assign permissions to each individual user, which would also require you to change those permissions every time somebody came or left the company. And generally, if you want to grant an individual more privileges or take away some of their privileges, you just change their role. If Mary leaves accounting, you take her out of the accounting department, and that's how you change the permissions. You don't have to edit the permissions on individual resources. So in the real world, we see lots of examples of role-based access control. Microsoft's Active Directory uses this, as does every implementation of Windows security pretty much. User Rights does this. The Family Safety, which is a tool built into Windows to give your kids less privileges on your computer than you, well, that uses role-based access control because you're either in the role of a kid or an adult. And if you're a kid, well, you're limited on the number of websites that you visit, and if you're an adult, you can visit any website. But you don't assign it to individual kids, like you don't give your son more privileges than your daughter, at least with this implementation of it. Instead, there's just the two roles, kids and adults. Facebook works like this too. You can create groups. So you make a group for your close friends, and you make a group for your coworkers. And if somebody takes a picture of you out drinking, well, maybe you share that with your close friends, but maybe you don't share it with your coworkers. You don't necessarily have to choose each individual person you want to see a picture. You can make groups to kind of simplify that, and that's an example of role-based access control. Airports do this too. You know how there's that separate security line for airport personnel so that pilots don't have to wait in the long line to get through? Well, that's role-based access control. The pilots are in a role for airport personnel, and you, as a civilian, you're in the role of regular Joe who gets to wait in the security line. So in this case, the people in the airport personnel role get additional privileges. They get to pick which of the lines that they want to go through, and if you're not in that role, well, you're limited in your privileges. Rule-based access control, again, it's not mutually exclusive with role-based access control. Rule-based access control simply defines a list of rules that control any given user's permissions over an object. These are commonly known as ACLs or access control lists, and Windows file permissions are an example. Firewall rules are also an example. Liquor stores are an example too. The liquor store rule is pretty simple. There's a rule that says over 21 allowed in, and then there's a default deny all rule. So if you don't pass that over 21 rule, you don't get in. And this is an important concept for rule-based access control. Every modern system now uses an implicit deny, which means if any given object has no permissions granting access, then it's denying access for everybody. And if you don't belong to a role that has permissions, or somebody hasn't assigned permissions to your specific user account, well, it's a deny for you. Now, you can go in and add an everyone full control rule over any particular object, but unless you explicitly do that, there's an implicit deny that blocks all access to every object. Now let's go over some information models, and I really want you to remember the details of these for the exam more so than the real world, because I find that it really doesn't come up in the real world, but it does come up in the exam, and I'll tell you why. Because it's easily testable. So I'm going to cover the 3 most common information models. And what you're going to see on the exam is a question that asks something like, which of the following traits is true for the Bell-LaPadula information model? And you'll have to pick the one that's right. Or you might see a question that says, which of these information models has a focus on integrity? First up, the Bell-LaPadula model. This is the one that's most relatable. It has a focus on confidentiality. So it has these levels like top secret, secret, confidential, and unclassified. And for the record, those are listed from most confidential to least confidential. And then it has 2 basic rules: no read up and no write down. So I'll explain those by example. Imagine that you're an employee with the secret clearance level. The no read up policy means that you could read documents at the secret clearance level and at the confidential and unclassified levels, because those are below your level. But because it says no read up, you couldn't read top secret documents. No write down means that you could write documents at the secret or even the top secret level. You would be able to write a document at the top secret level but not read it. But you could not write a confidential or unclassified document. And when you first hear these rules, they can be kind of hard to comprehend, but I can make it easy to remember if you understand the underlying concept, which is they don't want people to copy stuff to lower confidentiality levels. So you're working at the secret clearance level and you could read a secret document. They wouldn't want you to then copy it to an unclassified document. Therefore, your secret account can read confidential and unclassified documents, but it can't write them because that's preventing you from copying things to a lower level. That would be a lot like discretionary access control, right? Well, the Bell-LaPadula model is mandatory access control, and they don't want any loophole that allows users to change the confidentiality level of a document. So this is used really often with government mandatory access control systems. What they'll actually do in practice is they'll often give people multiple different consoles. So they'll have one, basically a keyboard and a monitor, a terminal that allows them to read secret documents. And then they'll have another one that allows them to access confidential documents. This will, basically they'll have multiple different clearances, and they can use their confidential computer to read confidential documents and write confidential documents, or read unclassified documents and copy stuff into a confidential document. That's new because you can write up, of course. But then if there's a secret document, well, they need to switch over to their secret computer, which of course wouldn't allow them to write a confidential document. So in theory, they could hop on their secret computer and read a secret document, and then hop on their unclassified computer and write an unclassified document, and maybe they'd copy stuff over that way. But because they're separate systems, they wouldn't simply be able to copy and paste. There'd be some manual work there, and you'd really have to go out of your way to bypass the security system. And that's what those 2 simple rules do, so I'm going to review them. No read up, that's a simple security policy, and no write down. That's just known as the asterisk policy for some reason. The BIBA information model is all about integrity. And integrity here means being able to trust that a document hasn't been modified. So whereas you think of Bell-LaPadula in the context of government security, I like to think of BIBA and Clark-Wilson, the next model that we'll talk about, as working best in a newspaper. It works rather opposite of the Bell-LaPadula model. There's no write up, which is called the simple integrity axiom. And there's no read down, which we know is the asterisk integrity axiom. So that's different, right? If you were to apply the same levels used by the Bell-LaPadula model, that would mean that at the secret level, you could not write a top secret document, but you also couldn't read a confidential document. You'd be able to write a confidential document, but not read it. And you could only read and write documents at your exact same level. Well, that's a bit confusing, right? So here's a good way to think of it. So imagine that you're an editor at a newspaper and you're working at the confirmed level. And your job, you're a copy editor, so you're going in and just fixing people's apostrophes and making sure every T is crossed and every I is dotted. You're doing really high-level stuff. You're not so much worried about the content. You're just fixing any grammatical problems. You're working at the confirmed level, and that means you'll be able to read and write at the confirmed level, but you won't be able to write at the trusted or unverified level. So you can do your job, and you're confident that everything in the document has already been fact-checked. Now, let's remove the constraints of the BIBA model and imagine that you as an editor can read any of the three levels. You're editing a confirmed document and somebody sends you a message that says, hey, can you paste this paragraph from an unverified document into the confirmed document? And you'll think, well, yes, I can do that. It's easy to copy and paste. So you go ahead and copy that unverified content over. Well, suddenly you've pasted a paragraph from an unverified document that hasn't been fact-checked into a confirmed document that everybody is going to consider as already fact-checked, and it can go to press with information that hasn't been double-checked. And that can be terrible for a newspaper. You could be printing incorrect facts, and imagine it's an incorrect fact about the President of the United States. This could lead to political disaster. It could tear the integrity of the newspaper apart. This can actually happen. And that's why you need these integrity models. No read down prevents you from accidentally tainting confirmed or trusted documents with unconfirmed data. So these three standard levels, unverified means, somebody calls in with a source. It could just be an anonymous guy. He could be making it up. You don't know. Trusted means that you've gotten it from a good source, but you're still taking that person's word for it. For example, you might be talking to a politician and he tells you that he was born in 1956. That's a trusted source. He probably knows what year he was born in, right? But politicians sometimes lie. And that's why there's a third level, which is confirmed. So if you have a fact checker that looks up his birth certificate and verifies that he was indeed born in 1956, well, suddenly that particular fact can be considered confirmed instead of simply just trusted. So this one piece of information might not have been changed from unverified to trusted to confirmed, but it has been checked. And you don't want something getting into the pool of confirmed information if it hasn't actually been fact-checked. Now, the Clark-Wilson model uses different techniques to accomplish the same goals. And in fact, Clark-Wilson can be pretty difficult to understand. And I'm not going to go into a ton of detail about it, but Clark-Wilson works by controlling how data is transferred between applications. And it separates applications, using separation of duty, from those who can read a document and those who can write the document. And, well, that sounds pretty obtuse, right? Like you use Word to both read and write different documents, but this separation of duty would allow an editor to read a paragraph in an unclassified document, but not be able to use the same application to add that same content to a classified document. And the process of moving data from one app to another is considered a transformative procedure, and it goes through all of these different security checks. So what I'd like you to understand about these is that the Bell-LaPadula model focuses on confidentiality. It is no read up and no write down. The BIBA model and the Clark-Wilson model both focus on integrity. The BIBA model says no write up and no read down, just the opposite of the Bell-LaPadula model. The Clark-Wilson model focuses on how data is transformed, and it provides separation of duty for different applications. This is Tony Northrup for Train Signal, and thanks so much for watching this video lesson.